Hi everyone, welcome to Lesson 8. This is our last lesson of our trigonometry unit. Lesson 8 is really quick today. We're going to just talk about graphing a tangent function. So all of lesson 4, 5, or basically 5, 6, 7, including a bit of 4, we graphed only sine and cosine functions. Now we're going to switch over to the tangent function. For example 1, and we only have the one example today, it says complete the table for tan x and then graph y equals tan x between 0 and 360 degrees. So first things first, if it says between 0 and 360, I want to double check the mode of my calculator, make sure I'm in degrees mode. There we go, hit enter on that. I want to type in tan x, and I'm probably going to switch my window setting. Um, 0 for x minimum, x max. Let's go up to 360 degrees, going up by 30 degrees seems reasonable. On our scale here for our y's, going down as far as it looks like 1, 2, 3, 4, maybe to -5 there. Uh, sorry, I put in some -5, -5 there. Going to +5, going up by 1 is perfectly fine. Let's hit graph really quick. I know that they want us to fill in our table of values here, but we're just going to graph this one out. And by the way, our table of values is going up by 45s, not by 30s. So that's going to be our graph. That's what we're ultimately trying to draw. Let's go to our table of values though. So if I go second graph on here, again, I don't want just 1 degree at a time. I want to go up by groups of 45. So go and play with your table starting at 0. Let's go up by 45-degree increments. There we go. Second graph now, and we do match up. So I'm just going to pull these values right off and fill in my chart here. So at 0 degrees, I'm at 0. So at 0 degrees, I'm at 0. At 45, I was at 1. At 90, let's take a look at our graphing calculator. At 90, it says error. An error on our graphing calculator means it is undefined. So I'm going to do 90 as undefined UNT. Even though our calculator says error, you don't ever want to write down error. You do want to write down undefined. Let's write down all the other ones. At 270, we're also undefined. So 270. There we go. The other number is at 135. We're at -101 there. So we're at -101 and at -10. Let's start off our graph with these undefined lines. A undefined line in this case here, of course, is a vertical asymptote. So in my graph here, I'm just going to draw two vertical asymptotes, one at 90, one at 270. There you go. So that means our graph is going to skip these lines, of course. There you go. Arrowheads on each end. Up next, you're just going to try to graph as many of these coordinate dots as possible. So at 0, 0, let's put a dot there. At 45, again, this is going up by 30s here, so it doesn't really help us. 45 is halfway there. 45, you should be at 1. And then we hit undefined. Okay, so that wasn't useful there. At 135, we're at -1. So this is 90, 120, 135 is right here. We're at -1. So we should go through that coordinate dot there. At 180, we were at 0. And at 225, which is right here, 225, we're at 1. And the only other two coordinate dots, so this is 270, 300, 315, we're at -1. And at 360, we're back to 0 there. So you can kind of start seeing the curve. If you want some of these other ones here, again, you can go straight to your graph and change your table of values. So this time, I'm going to change it instead of 45s. Let's go up by 30s because that's what our graph, um, that's what we have for our grid. And so again, you can guess and plug as many of these coordinates as possible in, and that's going to build a closer graph for you. So 30, you're at about half. At 60, 1.7 is right there. At 90 was an error. At 120, we're at -1.7. Should be right around there. 1.7, 1.5, right around there. Okay, so far so good. And after our 270 error, we're at negative 1.7 again for 300. So 300, negative 1.7 is down here. And that's probably going to be at negative a half there. So there we go. We have enough coordinate dots here. And again, I do want to sketch this graph here. And that's basically what I'm sketching. Down here, 180 is going to be our turning point, so our graph should be turning downwards to the left of 180. And it's going to look like it's going to loop upwards from 180. So 180 is a turning point. It's going to look something like that there. And of course, our little last section right here, which is also going down. And it would have gone up if you had more coordinates, so just leave an arrowhead there. So basically this is our graph, and so we're going to just fill in a few of these properties. That kind of sums it up for today. So what is our period? Well, our period's kind of hard to read. Notice that we start from 0, went to 90 asymptote, so that doesn't really give us a clear definition of what a period might be, because we might have something to the left here. Well, here, this middle section, we see our full graph. That's going to help us figure out our period. So our period is between 90 to 70. If you subtract that, that's just a period of 180 degrees. What's our amplitude? Well, our amplitude, the lowest and highest that we go, we actually have no idea. It goes on forever, so our amplitude is going to be undefined here. Do we have an x-intercepts? Yeah, we have 3 in this case here right now. We have 0, 180, and 360. And 360 degrees. And if we ever needed to write it in general, we can write something like, well, you're going at 180 degrees n, where n is an element of an integer. There you go, and you would, if you had that there, you would cover off all of these coordinates there. What's our domain? How far left and right are we going? Well, of course, as far left as negative infinity, as far right as, well, oops, we run into these asymptotes, so we want to write our domain in set notation because we have multiple graphs, by the way. So domain x such that we want x not to equal 90 or 270 degrees, but x can be an element of a real. It could be every other basically degree after that. You think of whatever you can think of. It could be all of them. And again, if you wanted to write down, let's say, your restrictions here, you can write down your restrictions in a generalized format. You could do something like x such that x cannot equal, instead of just saying 90 and 270, because what if it goes on forever? You can say 90 degrees is going to be the first one, and then you're adding on 180 degrees n to get to that second asymptote, where n is an element of an integer. So that's going to be your restriction, and then you're going to have x as an element of real. You could be everything else after that restriction. So there's curly bracket, and there you go. That's going to be my domain. For my range, well, the lowest we're going to go negative infinity, highest we're going is positive infinity. In this case, because we're already in set notation, I'm going to do range in set notation as well. So y such that y is an element of a real, and there we go, that's our range. Last but not least, equation of vertical asymptotes. So where are our two vertical asymptotes? So currently we have x equals 90 degrees, that's going to be the first one, and x equals 270 degrees, that's our second vertical asymptote. If you wanted to write it in general, what would it be? Or I could say something like 90 degrees. So I could say, sorry, x equals 90 degrees plus 180, and that's going to get us to that 270 there. N, where n is an element of an integer. And so you could, if this graph continued on, if we had a bigger window setting, you'll find all your vertical asymptotes using this equation. You'll find all your domain restrictions using the same equation, by the way. Okay, that's the end of lesson 8. If you have any questions about our tangent function here, please let me know.